All right, so looking at example number 2, AP Statistics. So we're back again with another question, continuing with our favorite golfer, Tiger Woods. Tiger Woods, I like him. And if you know where that comes from, you probably will not. That's just a line from a movie. But I digress. All right, so let me go ahead and put the information back here again. So the mean was 304 for our buddy Tiger Woods with a standard deviation of 8. So again, this was a normal distribution. Okay. So now this time we're going to ask a different question of our golfer. We want to know what's the probability that he's going to hit the ball anywhere between 305 to 325 yards. Okay, so that is a bit different. Okay, so first, what is it that we always do? We draw our lovely sketch of the normal curve. And I'm going to mark out, here we go, there's the mean, beautiful. And now I want to go ahead and mark, okay, 305. So the mean is 304. So 305 is going to be over here on this side. Okay. Doesn't have to be accurate. Just want to show that it's either above or below the mean. So 305 to 325. So let's say 325 is here. So we're interested in finding out this little slice of the entire population. What probability is that for us to land in that area? All right, so how do we go about figuring this out? First, I'm going to do it the hard way, which is using the table and doing it by numbers. So if I'm going to do it manually, remember that the table gives us only up to a single value. It doesn't do these two values. So I want to kind of be a little bit smart with this, going, well, if the table gives me from one end of the spectrum up to that point, I can pull a little geography. Boy, I'm in the wrong subject. A little bit of a geometry move here. And that is, well, if I go all the way to the outer number, so let's say, well, what if I shade in all this? So I'll figure that out first, and then I'll figure out this up to the 305, and if I subtract those two, then I'll be left with what I want. Perfect. That's what I would need to do if I were going to do this manually. So let's do that. So step 1, I'm going to need to get the z-scores for the 305 and the 325. Okay, so we're going to do those first. So 305, 325. Okay, so 325 minus the mean, 304, over the standard deviation, which is 8. And we'll figure that out right now. Whoops. Don't worry, nobody got hurt on that one. 325 minus 304. And then we'll divide that by 8. So we get 2.625. So I'm going to do a 2.63. Oh, sorry. Let me write 2.625. We'll round that to 2.63 because remember our table only goes up to 2 decimal places. So now we'll do 305. So 305 minus 304. So it's just going to give us 1/8. But again, I want to show my setup just in case if I fumble with using the calculator and I get the wrong number or happen to write down the wrong number, at least I'll get partial credit. Okay, so I got my z-scores. All right, so now step 2 is I'm going to get the areas corresponding to those z-scores. So I'm going to start with everything less than 325. So probability that we are less than 325. So that's this z-score here. So it's a positive 2.625. All right, so I'm going to go ahead and I'm going to look that up on my table. Now, what do I do in a case like this? Because it's only the 2 decimal places on the table. Do I look up 0.62 or do I look up 0.63? They will accept both ways of doing the work because they kind of get that you're kind of caught in between. If it were 2.629, then you should be going for the 2.63. If it were closer to 2.62, you should be going for that. So always we kind of, round accordingly. But in a case like this, since it's like dead in the middle, we go with the one, obviously 2.62, 2.63, it's fine. They'll work with either answer. They'll have an acceptable range for the solution. All right, so I'm going to go ahead and look that up. So all right, so I'm going to pull up my table here. So I'm scrolling through. So a 2.625. So if you look it up on your table, so a 2.62 would be a 9956. And if you went for the 2.63, you should be getting a 9957. So you see, it's really not a huge difference. When you get to large z values, very far away from the mean, you will see that. Like the numbers really don't change by much. So I'm going to go with the 2.62. So I'm going to use that 0.9956. All right. So 0.9956. And then I'm going to do the same thing now for our values less than or equal to 305. So now I'm going to look up 0.125. So this is going to be different. So 0.12 is a 0.5478. A 0.13, so if you round it up, would be a 0.5517. So I'm just giving you those numbers to ensure that you're looking at the right spot that I am. So I'm going to go, again, I'm going to do the same thing like I did with the other number. I'm just going to round down. So I'm going to do a 0.12. So a 0.5478. So a 0.5478. And now the last part is, as we said, here's where that geometry step comes in. We're going to subtract to get the desired area. So 0.9956 minus 0.5478. That's what the probability of getting between a 305 and a 325 distance on hitting the ball for Tiger Woods would be. So now subtracting those two numbers, so we get about a 0.4478. Okay, so about approximately around a 45% probability that we would hit somewhere in those distances. So as you can see, mucho work that I did here. So you might be wondering, wow, if this is so much work, I wonder what the calculator work looks like. It's really easy. That's why I did this part first. This is the harder way to do it, which is looking it up on the table, getting these numbers, doing the subtraction. But calculator, very easy. Because all we got to do for our calculator is write down the syntax. So I'm going to, again, go into my calculator, and I'm going to go under the distribution menu, and I do want to start writing down the syntax. So remember, it's that normal CDF, and I'm going to write down my arguments. So again, the visual over here, so let me erase this. So again, make it very clear what we're doing. Like so. So here's the mean. Here's that 305. There's that 325. So I want this. So the normal CDF, so the lower limit is 305. The upper limit is now 325. So we're in between two specific numbers. The mean was 304, and the standard deviation was 8. Again, I have to make sure I label. So don't forget, label upper mean standard deviation. Okay. Please be careful. I know I'm sloppy with writing my Greek letters. That's why I failed Greek handwriting back in the day. It's a lowercase sigma. So kind of practice writing it. Don't make it look like a 6, because then that looks weird. Okay. So sometimes you'll see me, I'll go back and I'll kind of fix it. Make it look like somebody smushed a 6. So I get that sigma look to it. So now I got this. So there's my work. And all I just got to do now is punch it in the calculator. So I'm going to do that very quickly here off to the side. I'm not going to pull up the graphing calculator quickly for this. So 305, 325, 304, and 8. Paste. And here we go. And we get that the answer is approximately 0.4459. So you can see, in comparison to our answer, it's fairly close. Okay, ours, remember, we approximated here, and then when we do this, it's another approximation. So it's not going to be as accurate as using the calculator. So the calculator is going to give us the more accurate response, but you can see it's not like it's completely off by tens or even hundreds. It's off by like the thousandth place. And that was due to, okay, when I got my z-scores all the way from here, so sorry, we actually were rounding here, to then get these numbers, and then so forth and so on. So that's how you can check, like, yeah, I'm getting the same response. Okay, so that's both using it, now let me label here, so this is calculator way, and over here this is table way. Either way, they're going to give you the full number of points for either method that you do. Most will opt to do it this way, because as you can see, man, I gotta show a lot more work over here just to get the same response that I can probably knock out by typing it into my calculator. So this is why it's important you get to use the calculator during the entire exam for all parts of the exam. So get comfortable using the tech. All right. So that does it for this example. I'm going to do one more example, and now we're going to actually, in the next example, go in reverse. So what happens if instead of giving me a score, I want to know what score I need to get to a certain percentage or certain probability. So we're actually going to go in reverse, and we'll see how to do that using the calculator as well as using the table. All right, so again, if you found this video to be informative, hit the like on the bottom, and I will see you guys on the next video.